Good evening, Lamai. Let's start the session for today. Today, we are going to discuss about the redox reaction balancing technique, which is known as the oxidation number change method. Right? Sometimes this is referred to as the direct balancing method. Right? Actually, with the last class, we had discussed about the first technique of balancing redox reactions. Right? That was actually the half reaction method. We had gone through that, right, and done some exercises as well. Today, this is the second method we are going to learn, right? That is the direct balancing method, which is also known as the oxidation number change method, right? Okay, let's begin with that, right? So, even in the oxidation number change method, there are 4 main rules to follow, right? I'll first write the 4 rules, then we'll take an example and use those rules to come up with the final answer, right? Okay, when it comes to oxidation number change method, right, the 4 steps to follow, right? There are 4 steps. There are 4 steps to follow, right? Actually, those are the 4 steps we had used, right, with the step B of the half reaction balancing technique, right? Let's quickly get some idea about the 4 steps there, right? The step number 1, right? Step number 1 is balancing the redox atom, balancing the redox atom, right? Step number 2 is balancing the oxidation state. Actually, for that we use electrons, right? The third step we need to follow when balancing a redox reaction with the use of this technique is actually balancing the net charge. Balancing the net charge. Right? For that, we can use the medium. Using the medium. If it is an acidic medium, you have to use the H pluses. If it is a basic medium, you have to use the OH minuses there, right? Okay. The fourth step to follow is actually balancing the hydrogens and oxygens. Hydrogens or the oxygen. For that, we use the H2O molecules. Using H2O, right? These are the 4 steps to follow when you are supposed to balance a redox reaction with the direct method or the oxidation number change method. Let's come up with an example, right? Let's come up with this example now. Example, right? Let's try to balance this reaction, balancing the acidic medium reaction involving dichromate and SO2, which ultimately produce the Cr3 plus ions as well as sulfate ions. Let's try to balance this reaction, this redox reaction, basically with the use of oxidation number change method. Let's use this technique, right? Okay. So this is the balancing scenario, right? Right. First step. Step 1. Step 1 is actually balancing the redox atom. Balancing the redox atom. Redox atoms actually, right? Balancing the redox atoms, right? Okay. So here we have the right. Here we have the Cr2O7 2 minus and the SO2 forming Cr3 plus and the SO42 minus. Right? What are the redox atoms here? The chromium is one of the redox atoms, right? So balancing chromium is one thing. So you have two chromiums here. So you need to come up with two here as well. Right? You have one sulfur here, and here as well you have only one sulfur. So no need of any numbers there to balance the sulfur. Right? So that is how we are supposed to balance the redox atoms. That is the first thing to do. Right? Number two. That is balance in the oxidation states using electrons. Right? This is the next step. Right? See how to do that thing. Right? For this, actually we use the least common multiple. Right? So one can say this is also referred to as, right, the use of least common multiple. See, so our equation is balanced up to now, up to this case, right? Up to this stage, now the equation is balanced. Let's try to use the least common multiple to balance the stuff, right? So it's like this, balancing oxidation states here, right? So when it comes to oxidation state of these two chromiums, 7 oxygens carries minus 14, 7 oxygens carry minus 14, right? So this could be plus 14 minus 2, it is plus 12. That plus 12 is the summation of oxidation states for dichromate, right? Here you have 2 of plus 3s, 2 of plus 3 ions, right? So the oxidation state difference here is how much? Plus 12 plus 6, that means 6 electron difference, 6 electron difference, right? What about this? 2 oxygens means minus 4, so this sulfur should carry plus 4, right? So here 4 oxygens means plus 8, so for this sulfur, 4 oxygens means minus 8, 4 oxygens means minus 8. For this sulfur, it is plus 8 minus 2, plus 8 minus 2, that is plus 6, right? So what is the difference here? So the difference of oxidation states here is actually 2 units, right? So now we need to use the least common multiple to balance the oxidation states, right? So these 6 electrons, these 2 electrons, the least common multiple is 6, right? The least common multiple is 6, right? So one can write like that, right? So your, right, least common multiple is equal to 6, right? So you have to balance the stuff according to 6, right? To come up with 6, you need to multiply this thing with 3. You need to multiply this thing with 3. So put 3 for that branch, right? You have to multiply both the chemicals responsible with that branch with 3 to come up with the least common multiple. This should be multiplied with 1, no? This should be multiplied with 1. So just write 1. No need of writing 1, no? Right? So that is the idea. So this actually says when dichromates converts to Cr3+, then dichromates convert to Cr3+, 6 electrons have been absorbed. That is why the oxidation state decreases, no? Reduction, no? 6 electrons have been absorbed. Those 6 are actually provided by the 3 of SO2s when they convert to 3 of SO42 minuses, right? When 3 of SO2s convert to 3 of SO42 minuses, right? 6 electrons have been released, right? So those are 6 electrons absorbed by the dichromates to convert to 2 of Cr3 pluses, right? Okay. So that is the second step where we had balanced the oxidation states with use of electrons or with use of least common multiple, right? Okay, that was the second step. Let's come to the third step. Step number 3, right? step number 3. That is actually balancing the net charge. Balancing net charge actually using the medium. Here the medium is acidic medium, so here we use H pluses. Here it's H pluses as the medium is acidic, right? Right, let's balance the stuff. So our equation is balanced up to here. Right? Up to here the thing is balanced. Right? So let's try to balance the net charge here. So with this side, what is the net charge? You have one particle with -2. Here you have 3 particles with 0 charge. So these 3 guys gives you 0. One particle with -2 gives you -2 charge. So net charge here is -2. With this side, so you have 2 particles with +3, that means +6 altogether from these 2 Cr3 pluses, and 2 particles with -2. 3 particles with -2. -6 +6. So the net charge is 0. Net charge is 0 there. Right? Net charge is 0. Right? This is done. So the difference in charges is actually all about 2 units. 2 units of difference between the charges of the 2 sides, right? So you need 2 of H pluses to balance the charges on both sides, right? So 2 of H pluses needed. To which side we are supposed to add that? We are supposed to add the 2 H pluses to the side with least positive nature. To the side with least positive nature, we are supposed to add the H pluses. That is this side. So to that side, we are supposed to add the 2 of H pluses. 2 of H pluses, right? Okay. So that is the third step, right? Now the fourth step. Right? That is all about balancing hydrogens. Right? Hydrogens or the oxygen. So we can balance the hydrogens or oxygen, anything, right? For that, we use H2O molecules, right? Balancing hydrogens with the use of H2O molecules here, right? Okay. See how to do that. So the thing is balanced up to here, right? 3 of SO2, right? Let's try to balance the hydrogens. Here you have 2 hydrogens at this side, but this side you are not with any hydrogens, right? So number of hydrogens, here it is 2. Here the number of hydrogens is 0, no? So 2 units of difference. So you need to come up with one H2O molecule to balance this stuff, right? So one H2O molecule should be added to this side, to side with least hydrogens. To side with least hydrogens, you need to add the water molecules, right? 2 hydrogen difference is there, so one H2O will be enough to provide the 2 hydrogens, right? So that is the fourth step. So this is how you are supposed to balance the ionic equation with the use of half reaction balancing technique, right? So these are the 4 steps you should follow. Balancing redox system first of all, then balancing the oxygen state using the electrons, or one can say using the least common multiple, then balancing net charge, right, using the medium, and finally balancing the hydrogens or the oxygens. For that we use water molecules, right? This is how a reaction is balanced with the use of direct method or oxygen number change method, right? So So basically this is referred to as oxidation number change method because of this thing, right? Because you are trying to get the least common multiple, no, right? So one can say this is as 2 and this is as 3, no. So if you take the smallest value here, right, this is 1, this is into 3, no, so 1 to 3 there, so that 3 is written with the other guy and the 1 is written with this guy, right? That is why that method is referred to as the oxidation number change method as well, right? Anyway, it is easy to take the least common multiple and write the stuff, right? Okay, this is the method we are using to balance the redox reactions by the direct method, right? The thing is clear, right? So let's try to solve a few more questions like this, right? The thing is clear, right? So you can complete this stuff, right? And then we'll do some exercises which are actually appearing at the page number 32, right? Sorry, 31, right? Okay, this clear, right? Okay, Lama, let's try to solve this question which is appearing at the page number 31, the question number 10, right? So we are supposed to solve this one with the use of Ditrect method, right? Oxidation number change method, right? Let's try to do this stuff, right? So here the reaction is in acidic medium, you are doing this reaction. So basically you are adding here the Mn4 minus ions and the dichromate ions to come up with Mn2 plus CO2 and H2O to provide the acidity to the medium. The H2SO4 is used, and to provide the Mn4 minus ions, the KMnO4 is used, and to provide the oxalate ions. Sorry, this should be oxalate C2O4 2 minus. To provide the oxalate ions, right? They had used potassium oxalate, right? So let's try to balance this stuff, right? Okay, right. First thing, right? First thing is actually to balance the redox atoms, no? First thing is to balance the redox atoms, right? Let's try to balance the redox atoms here. So you have one manganese here, so that is balanced. So you have two carbons here, but only one carbon there. So first of all, you need to come up with some 2 here, balancing the redox atoms. That is done. Then balancing the oxygen states with the use of electrons, right? Or with the use of least common multiple. Let's do that. So here, the oxygen state of Mn, manganese here, is the +7, right? -8 is there. So for this number, -8 +8 -1 is +7. For this one, -8 is there. So for this number, right, +8 -2, that is +6. For the 2 carbons, it is +6, right? So here it is a +2 monoatomic, monoatomic ion, right? So here, for 2 oxygens are there, so -4 for the carbon, it is +4, and such 2 are available, so 2 of +4s, right? So the difference here is actually +7 to +2 is difference is just 5 units, and difference here is +6 +8, just 2 units. So least common multiple becomes 10. The least common multiple is 10. So you need to multiply this thing with 5. Least common multiple is 10. So you need to multiply this thing with 5. That means this becomes 5, and this becomes 5 into 2 is 10. 5 into 2 is 10. This becomes 10. Right? So what about this thing? So to come up with the least common multiple, which is 10, you need to multiply this thing with 2. So this branch, the 2 chemicals of that branch should be multiplied with 2. Right? So that is the second step. Balancing the oxygen states with the use of electrons or the use of least common multiple. Right? Okay. Next one. Balancing the net charge. Here, net charge is -2 and you have 5 particles with minus 2, that means minus 10. Minus 10 and minus 2 is minus 10 and minus 2 is minus 12. Minus 12 altogether. Right? At this side, you have plus 4, 2 particles with plus 2 charge, plus 4, and here is 0, it is plus 4 altogether, the net charge. The difference between the net charges is actually 16 units. It's like that, no? So you have minus 12, 0 is there, and plus 4 is there. So between these two, 12 units are there, between these two, 4 units are there, altogether 16 units of difference. So 16 units of difference with the charges. So that you need 16 H pluses. You need 16 H pluses as the medium is acidic. So 16 H pluses should be added to the side with least positive nature. That is this side, no? So 16 H pluses. Just add 16 H pluses. Right, no? So the final step, you need to balance the hydrogens with the use of H2O. At this side, you have 16 H pluses, 16 hydrogens. At this side, you have no hydrogens. That means 16 hydrogens and no hydrogens. It means 16 units of difference with the hydrogens. To provide 16 units of hydrogens, you need 8 water molecules. 8 water molecules, right? So that should be added to the side with, right, least hydrogens, right? So that is this side. So 8 water molecules should be added. So that is the answer, right? That is how you are supposed to balance the equation here. And this is referred to as the balanced ionic equation, right? This is referred to as the balanced ionic equation, right? This thing is referred to as the balanced ionic reaction or balanced ionic equation, right? Let's try to come up with the balanced chemical reaction as well, right? Let's try to come up with the balanced chemical reaction. Let's try to balance that thing as well. Balance chemical reaction, right? When thinking of balanced chemical reaction, right, there could not be any ionic species there, right? When you are supposed to convert the balanced ionic reaction to the balanced chemical reaction, you can't have any ions there. All the ions should be converted to the, right, uncharged species, chargeless species, right? Let's try to do that thing. They are saying that the H2SO4 is used to provide the acidity, provide the H pluses to the medium. KMnO4 is used to provide the MnO4 minus ions to the medium, and potassium oxalate is used to provide the oxalate ions to the medium, right? Let's use those things, use chemicals to balance the reaction, or to come up with the balanced chemical reaction, right? Okay, let's do the stuff, right? So to provide 16 H pluses, you need how many H2SO4 molecules? You need 8 H2SO4 molecules, right? 8 H2SO4 molecules are able to provide 16 H pluses, right? So when you are writing 8 H2SO4 molecules, right, you had written 8 SO4 2 minus ions in hand, right? By hand you had used 8 SO4 2 minus ions. 8 of SO4 2 minus ions you had written by hand, right? Okay, right. Because all of these things you have used by hand should be written at the other side as well, because so far the reaction is balanced, right? If you are doing some change to one side, the same changes should be done to the other side as well, right? Okay, right. So to provide the MnO4 minus ions, you can use the KMnO4, because the KMnO4 is used to provide the MnO4 minus ions. That is what the question says, right? So to provide 2 of MnO4 minus ions, you need 2 of KMnO4s, right? Okay, so that you had added 2 of K pluses by hand, 2 of K pluses by hand. So it should be added to the other side as well, right? Okay, so then to provide the C2O4 2 minus ions, you are supposed to use the K2C2O4, right? You need such 5 of C2O4 2 minus ions, so you need to come up with 5 of potassium oxalates, right? So that you had added 10 K pluses by hand. So that 10 and this 2 all together is become 12 K pluses by hand, right? So you need to provide those things to the other side as well, right? See? So to neutralize the charge of Mn2 plus, you can use these things what you have added to this side, right? Because those should be written on the other side as well, right? So provide to neutralize the Mn2 plus, the negative charges can be provided by the SO4 minus ions there. So that is going to be MnSO4 now. So as you are supposed to come up with 2 of Mn manganese ions, so it need to be 2 here. So that means I had used 2 of sulfates with me. I had used 2 of sulfates with me. Earlier it was 8, now I had used 2. That means this becomes 6. 6 sulfates are remaining now, right? Alright, okay. Next one. This is a chargeless species. Just write that thing as it is. And you have 8 H2 molecules. No need of worrying about the chargeless species, right? Finally, right, you have to write the remaining things you have added to the left hand side to the right hand side as well. So you have 12 K pluses and 6 sulfates. So basically first write the formula of these two guys. K plus connecting with the sulfate, that is going to be K2SO4, K plus connecting with the sulfate, exchange of valencies SO4 2 minus, and K plus, that is K2SO4, as you are with 6 of K plus 12 of K pluses and 6 of sulfates remaining, so that should be 6 here. That will provide the 12 K pluses as well as 6 of sulfates. So this is your balanced chemical reaction. That is your balanced chemical reaction, right now. So that is how you're supposed to complete this kind of a redox reaction. Right, let's complete the work. Okay, Lamai, let's do this second question. Let's solve this second question as well with the use of direct balancing technique. Right? Okay. First thing is to come up with the balanced ionic reaction. Right? First, let's come up with the balanced ionic reaction. Right? First, write the chemical species there. This thing with Cl minus reactants to produce the Cr3 plus and the Cl2. Okay, right, let's write. So first of all, balancing the redox species, balancing the redox atoms, right? You have 2 of chromiums here, just 1 chromium, so you need to come up with 2 here, balancing the redox atoms, right? 1 chlorine, 2 chlorines, so you need to add 2 here, right? So balancing the redox atoms. That step is done, right? Okay. Next step, balancing the oxygen states with use of least count multiple over the electrons, right? Okay, let's do that step, right? So here minus 14 is there, minus 14 is there. For these 2 chromiums, it is plus 14 minus 2, that is plus 12. So 1 Cl minus carries minus 1 oxygen state, such 2 are there. So minus 1 and minus 1. So altogether minus 2 there, right? Okay. So 1 chromium carries plus 3, such 2 guys are there. So altogether plus 6 is there, right? So this is 0, elemental form, right? The difference, taking the difference. Here, the difference is 6 units, plus 12 and the plus 6, 6 units. Here, minus 2 and the 0. Difference is actually 2 units. Right now? Okay. Now we need to balance this stuff, right? 2 oxygen states should be balanced, right? So to balance this one, so the least common multiple is becoming 6 here. For the 2 and 6, it is the least common multiple is 6. So you need to multiply this thing with 3. Multiply this thing with 3. Right? So that means this branch should be multiplied with 3. So 3 into 2 is 6. multiplied with 3 means this 3. Right? So this should be multiplied with 1 to come up with the least common multiple. So 1 is no need to write there. Right? Okay. Next one. The second step is done. The third step is actually balancing the net charge on both the sides. Net charge. Right? So this side, when it comes to left hand side, the charge of this thing is -2. You have one particle with -2. You have 6 particles with -1. -2, -2, -6. That means -8 altogether. -8 altogether. The charge in this side, right? Charge at this side is +6. 2 particles plus 3 means +6, and 0 here. 3 particles 0 means 0, right? So +6. So altogether you could see 14 units of difference. 14 units of difference. -8 and +6. You have 14 units of difference, right? So 14 H pluses. 14 H pluses should be added to this side to balance the 14 units. So to balance the 14 units of difference, you need, right, 14 H pluses as the medium is H plus, right? So to the side with least positive nature, that is this side, so that 14 H pluses are added to this side, right? Okay. Next point, the last form is actually balancing the hydrogens and oxygens with use of water. So you have 14 hydrogens at the left hand side. At the right hand side, you don't have any hydrogens. So 14 units of difference among hydrogens at the both sides, right? So you need to supply 7 H2 molecules to provide that 14 units of difference, right? 7 H2 molecules to each side, to the side with least hydrogens, right? So this is that side, right? So you need to add 7 H2 molecules there. So this is referred to as the balanced ionic reaction or balanced ionic equation, right? So where the ions are appearing, right? Next task is to come up with the balanced chemical reaction. Let's try to write the balanced chemical reaction here, Lamai. Balanced chemical reaction. Balanced chemical reaction, right? So to provide the H pluses, they have given you the H2SO4. To provide the dichromates, they have given you sodium dichromate, right? Sodium dichromate, it is Na227, right? So to provide the Cl- ions, they have given you NaCl. Let's try to balance, right? So H pluses are provided by the H2SO4. So just write H2SO4. You need to come up with 14 H pluses. To provide 14 H pluses, 7 H2SO4 molecules are enough. So by hand, I have added 7 SO4 ions to the balanced reaction, right? So these things should be written at the next slide as well, right? So to provide dichromate, they have used sodium dichromate, right? Just write formula first of all, and you need only 1 dichromate ion, so 1 sodium dichromate is enough. So that when writing this, you have added 2 of sodium pluses by hand, right? Next one, to provide the Cl- ions, they had used NaCl. So you need such 6 Cl- ions, so 6 of NaCls are needed. So that when writing this, you have added 6 Na pluses. That 6 and these 2 altogether it is 8 Na pluses, right? Now we need to provide these things to the other side to neutralize them first of all. So you have Cr3 plus ion, right? So neutralize the Cr3 plus as a negative ion. You are with sulfate here. So chromium sulfate should be the species written at this side here. So Cr chromium sulfate. So exchange the valencies. Cr3 plus. So SO4 tries. SO4 2 minus, no? So 2 here. Just exchange the valencies. To provide 2 of Cr3 plus ions, 1 chromium sulfate is enough. 1 chromium sulfate is enough. When writing this, you had used 3 of sulfate ions. You had used 3 of sulfate ions. So altogether 7 was there. You had used 3. So only 4 is remaining. 4 of sulfates are remaining. Right? So this is a chargeless species. So just write that thing as it is. And this is also a chargeless species. 7H2O. And finally, what you need to do is just write the remaining ions here to the give those remaining ions here to the other side, right? Because all the things I have added by hand for the left hand side should be written at the right hand side as well, right? Okay, so you have sulfate ions and the sodium plus ions, so those things will be connected to form the sodium sulfate. So for 2 minus, no, so 2 comes here in Na plus, right? And how many number of sodium sulfates are needed here to balance the stuff? So you have with 8 in Na pluses and 4 of sulfates, so that 4 of sodium sulfates will provide the 8 in Na pluses and the 4 sulfate ions, right? So this is your balanced chemical reaction, right? No, that is question number 2, right? Just complete the stuff. Right, let's try to solve the third question appearing at the page number 31, the question number 10, right? This is the third one, right? First, we are supposed to come up with the balanced ionic reaction. Let's write that thing. Balanced ionic reaction. Balanced ionic reaction, right? Okay, first of all, just write the chemicals appearing there, reacting with FeO, forming Mn2 plus and Fe3 plus, no? Right. Let's start. First step is to balancing redox species, right? Okay. So redox species, you have one manganese ion here, so one manganese stuff here, one, that is balanced. One Fe there, one Fe there, so those are balanced. First step is done. Second step, balancing the oxygen states with use of electrons. So here you have -4 appearing with the 2 oxygens, so that the manganese should come up with +4. This one Fe -2 here, so here +2. So here this guy is with +2 and this guy is with +3, no? So let's come up with the change in oxygen states, +4 to +2. That means 2 electrons are transferred. Actually 2 electrons are gained by this one to become here. So +2 and +3, so 1 electron difference. So take the least common multiple, 2 and 1, 2 and 1, that means least common multiple is 2 here. So you need to multiply this thing with 2, right? So that all the things with that branch should be multiplied with 2. Multiply this thing with 1 to take the copy the least common multiple, right? Okay, multiplying with 1 means no need to write, right? Okay, the second step is done. Third step, balancing the charges on both sides, right? This side. So one particle is 0 charge, 2 particles with 0 charge. The charge is 0. The charge here is 0. Here, one particle is +2, 2 particles is +3. 2 particles with +3 means +6. Another +2 is there, +8. So 8 units of difference. 8 units of difference. So that you need to come up with 8 H pluses to balance this charge because the medium is acidic, right? So 8 H pluses should be written at the side with least positive nature. So this is the least positive situation, right? So to that side, that 8 H pluses should be written. The fourth step is actually balancing hydrogens, right? So at this side you have 8 hydrogens, at that side you don't have any hydrogens, right? So that you can clearly see, right, 8 units of hydrogen difference. That means you need 4 H2O molecules to balance those 8 hydrogens. So that should be added to this side as the side with least hydrogens, right? Okay, the 4 H2Os should be added there. So this is your balanced ionic reaction, right? Let's try to come up with the balanced chemical reaction as well, right? balanced chemical reaction. Right? To provide the H plus science, they have used H2SO4. To provide the MnO2, just use the MnO2, and to provide the FeO, just the FeO is used, right? Okay, let's write the stuff, right? So to provide the H pluses, they had used H2SO4s, right? Let's write the H2SO4 there. We need to come up with 8 H pluses, so that 4 of H2SO4 should be used, right? So I have added 4 SO4 2 minus ions by hand. Those should be written at the right hand side as well, right? So these are uncharged species, so chargeless species, just write them as it is, right? Go to the next one, next side, right? So manganese, you can use the anions with me to neutralize the charges of the left hand side. So the positive charges are there, so you can use anions from here, right? So manganese can be connected with SO4 2 minus ions to come up with MnSO4. You need only one manganese there, so one is there, so one of SO4 2 minus is used, so that means this becomes 3 now. One is used, only 3 is remaining. What about this thing, right? So this guy connecting with the sulfate ion like this, SO4 2 minus, no, so that 2 comes here. If you 3 plus, no, that 3 comes here. Exchange of valencies, right? So this will give you the 2 of Fe3 plus ions, right? Okay, and all the 3 sulfates have been used when writing this formula, right? So the 3 sulfates which was with me was used, right? So that is gone, right? So just write the chargeless species there, the water. So this is your balanced chemical reaction, right? Now just complete the stuff now. Okay, let's try to solve the question number 4, right? Okay, this one is the reaction. So in basic medium, aluminium is reacting with NO3 minus ions to provide the OH minus ions. The medium NOH is used, aluminium providing aluminium, and NO3 minus ions are provided by sodium nitrates, right? Okay, let's try to write this one. First of all, we are supposed to come up with the balanced ionic reaction, right? Balanced ionic reactions. Balanced ionic reaction. Let's write the stuff, right? So first write the chemicals there. Sorry, let's write the chemicals there. Aluminium with NO3 minus, right? You're not supposed to write the medium first of all, right? Just write the redox couples, right? Aluminium with AlO2 minus, that is one redox couple. The second redox couple is the NO3 minus and the NH3. That represents the second redox couple, right? Let's write those things. Then let's start balancing. First step, balancing the redox atoms. One aluminium, that is balanced. One nitrogen, that is balanced. The redox atoms are normally the atoms other than the hydrogens and the oxygens, right? So that is true for 99% of the times. That will be varied only with the H2O2 stuff, right? With the hydrogen and oxygens are available. The other redox atom is going to be oxygen. Other than that situation, normally that is how you are supposed to come up with the redox atom, right? The atom which is not the hydrogen or the oxygen with your species, right? Okay, so that is done. So next step, balancing the oxygen states. Here the oxygen state is 0. With this aluminium, it is what? With this aluminium, minus 4 is there. So this is plus 3 minus 1, that is minus 4 is there. Plus 4 minus 1, this is plus 3. Right? Minus 4, that means plus 4 minus 1 is plus 3. So how many of difference here? Just 3 units of difference there. What about this thing? So you have minus 6, minus 23 is minus 6. This guy's value is plus 6 minus 1. Plus 6 minus 1, that is plus 5. For this thing, you have plus 3 with the 3 hydrogens. Plus 3 with the 3 hydrogens. So nitrogen should carry minus 3. Right? Let's balance the. You have to come up with the difference between the two. So plus 5 and the minus 3. Plus 5 and the minus 3. You have it 8 units of difference. You have it 8 units of difference. Plus 5 and minus 3. Right? So least common multiple becomes 24. To come up with 24, you need to multiply this thing with 3. So the things at this branch should be multiplied with 3. They should be multiplied with 8 to come up with 24, which is the least common multiple. So the species at this branch should be multiplied with 8. Right? Okay, that is was the completion of the second step. Third step, balancing the net charge. 0 here, minus 3 here. So net charge is minus 3 here. Here, minus 8 here. Here 0. That is minus 8. The difference is 5 units. Difference is 5 units. Right? So you have to use the medium to balance that 5 units. Right? You have it OH minus as your medium. So 5 of OH minuses are needed. 5 of OH minuses are needed to each side. To the side with least negative nature. The OH minus carrying some minus. So to the side with least negative nature, that is this side. Right? So 5 of OH minus are added to that side. Right? No? Okay. Next is the time to balance the hydrogens. So here at this side you have 5 of hydrogens, but at this side you have 9 of hydrogens. 9 hydrogens, 5 hydrogens here. So 9 and 5. 4 units of difference. 4 units of difference. To provide 4 hydrogens, you need 2 of H2 molecules. 2 of H2 molecules to each side. To the side with least number of hydrogens. This side you have with 9 hydrogens. This side you have with 5 hydrogens. So that this is the side with least number of hydrogens. So you need to add 2 of H2 molecules here to that side. So you clearly see here the medium and the water can come to the same side. Water and the medium can appear at the same side. No worries. Just what you need to do is just following the rules correctly. Right? Okay. That is the third step. The fourth, that is the completion. That is so the completion, final step, right? Balancing the hydrogens with use of water. So that is how we are supposed to balance the ionic reaction. Let's copy the overall chemical reaction as well. Balanced chemical reaction. To provide the OH minus ions, they have used the NaOH. To provide the nitrate ions, they have used the sodium nitrate. Right? Let's copy those. Right? So the 2 of H2O will appear as it is. 5 of OH minus means there should be 5 of NaOH. To provide the OH minus ions, they have used NaOH. So by hand, I have added 5 of Na pluses. Right? Then you have the aluminium. No worries, you can write that thing as it's a chargeless species. And 3 of nitrates. To provide the nitrate ions, they had used sodium nitrates. Yeah. So to provide 3 of nitrates, you need 3 of this. That means by hand you have added another 3 of Na pluses. That means altogether 8 Na pluses you have added. When come to this side, you can use the positive ions available with you to neutralize the negative ions here, so that when this is used with the Na plus, it is NaAlO2, Na plus and Al2 minus, right? The exchange of valencies. You need such 8 aluminiums, right? So when writing 8 aluminates, right, you had used all the Na pluses. You had used at the left hand side, right? Okay, and then the 3 of NH3s. So this is your balance chemical reaction. Let's complete that. Let's try to balance the equation 5 appearing at your study questions, right? Equation 5. It is like this. The basic medium zinc reacting with NO2 minus to produce the zincate ZNO2 minus and the industry. Let's try to balance this one, right? So first write the redox couples, right? Zinc and ZNO2 minus, that is one redox couple. The other redox couple is NO2 minus and the industry. Let's try to balance this one. Right. First thing is to balance the redox atom. One zinc, that is balanced. One nitrogen, one nitrogen. So that is also balanced. Redox atom is balanced. Now you need to balance the oxygen states, right? Here it is 0. For this one, it is -2 into -4. This guy +4 minus 2 is +2. So 2 units of difference, right? 2 units of difference there. What about this? -2 into -4 +4 minus 1 is +3. Here +1 into is +3, so this should be -3. So the difference is 6 units. These come multiple. 6 and 2. This come multiple is 6. So you need to multiply this thing with 3. Right? So this chemical species at that branch should be multiplied with 3. This is with 1. No need of multiplying there. Multiplying with 1 means just 1. No need of writing anything, right? Okay. Next, oxygen states are balanced now. Then charge balancing with the use of medium. Here the medium is basic medium, right? So you are with -1 charge at this side, 0 here, -1 here. At this side you have 3 particles -2, that means -6. No charge here, right? So charge balancing -1 and -6, 5 units of difference, 5 units of difference, right? -1, right, and -6, 5 units of difference. That means you need to come up with 5 OH minus ions to the side with least negative nature. So that is this side. So 5 OH minus ions should be added here. Finally, the hydrogen balancing. You have 5 hydrogens here, you have 3 hydrogens here, 2 units of difference. So 2 units of difference means you need to come up with 1 H2O molecule, 1 H2O molecule. That means that should be added to the side with least number of hydrogens. So that is this side. This side you have 3 hydrogens, this side you have 5 hydrogens. So you have to come up with some H2O at this side. Right, no? So that is how you are supposed to balance this stuff. Right, no? Let's complete this one. This is referred to as the ionic equation, balanced ionic equation, right? So we need to come up with the balanced chemical reaction as well, right? Balanced chemical reaction also should be written, right? Let's do that stuff as well, right? So let's come up with the balanced chemical reaction. Right. To provide the OH minus ions, they had given us the KOH. To provide the NO2 minus ions, they have given us the KNO2, right? Let's use the stuff, right? So to provide 5 of OH minus ions, so that you need 5 of KOHs, right? That means you had used 5 of K pluses by hand, right? then 3 of zinc thing available here. Then as the NO2 minus ions, they have given you the KNO2 to provide the NO2 minus ions. So KNO2, we need such only one species, right? So by hand another 1 K plus is added altogether. The amount of K plus added to the left hand side is 6, right? Okay. So to copy the zincate, you can use the K pluses because for negative ions you can utilize negative ions by positive ions. So potassium zincate. So exchange of valencies 2 minus here comes to here. The thing is okay. Exchange of valencies, right? So you are supposed to copy 3 of zincate ions. So 3 is needed. When forming this thing, all the 6 K pluses are used. All the 6 K pluses are used, right? So rest are the chargeless species. So NH3, NH2. So that is your balanced chemical reaction, right now. So you will complete this stuff as well. This is the question number 5. Okay, now let's try to solve the question number 6, the 6th case here, right? So that is the question here. So in acidic medium, MnO4 minus ions react with Fe3O4 to copy the Mn2 plus and Fe3 plus. So to provide the H plus ions, they have given you the H2SO4, and to provide the MnO4 minus ions, they have given you KMnO4, right? Okay, let's try to come up with the ionic equation first. So balance ionic equation. Ionic reaction. Right. So first write the redox couple, right? N4 minus and the Fe3O4. Give you the Mn2 plus and the Fe3 plus, right? Let's try to balance this one. So first of all, balance in the redox atoms, right? 1 manganese, that is balanced. 3 of iron atoms are there, so you need to copy 3 here. Balance in the redox atoms, right? So balance in the oxygen states then -8. So this is +8 minus 1 is +7, right? So this one -8 minus 21 -8. So all these guys should carry +8. The summation is what we are looking at, right? Okay. So +2 here. 3 of +3s, that is +9. 3 into +3s, right? So you have 3 atoms, right? Ions with +3 oxidase, right? So that is +9 altogether. So differences, right? So 5 units of difference here. +7 give you +2 is 5 units of difference, right? So here +8 give you +9 means just 1 unit of difference, right? How units of difference you can see here? That is actually first of all you need to copy the least common multiple. So 5 and 1, that means least common multiple is 5. So you need to multiply this thing with 5, right? So this branch should be multiplied with 5. So 5 into 3 is 15, no? 5 into 3 is 15. And this branch is 1, right? This branch is 1. So oxygen states are balanced. Now the charge balancing, -1 is there, 0 there, so -1 is the charge for this side. So this side +2 is there, +15 into 3, so +45 is there, +45 and +2 is +47. So altogether 48 units of difference. 48 units of difference. So you need to use 48 H pluses as the medium is acidic. 48 H pluses should be used, and H plus should be added to the side with this positive nature. That is this side, right? So 48 H pluses should be added here. Finally, we need to balance the hydrogens. so that you can see 48 hydrogens here and no hydrogens here. So that means 48 units of difference with the hydrogens. That means you need to come up with, right, 24 H2Os. You need to come up with 24 H2Os, right, to provide 48 hydrogens, right. So 24 H2Os should be added to the side with least hydrogens, that is that side, right. Okay, so 24 H2Os. This is your balanced ionic reaction, right. Let's come up with the balanced chemical reaction as well. Right. Okay. To provide the hydrogens, they had used H2SO4. So just write that thing, H2SO4. So you need 48 hydrogens. That means you need to come up with 24 H2SO4s to provide the 48 hydrogens, right? So I have added 24 SO4 to minus signs by hand, right? Okay. So to provide the MnO4 minus signs, they had used the KMnO4. So just write it as KMnO4. So for that, I added 1 K plus sign by hand, right? Just write them because you need to apply those things to the right hand side as well, right? So this is a chargeless species. Just write that thing as it is. Okay. And Mn2 plus is a positive ion. You can use the negative ions with you to neutralize that thing. So sulfate ions are with you. So Mn2 plus and SO4 minus. So it is manganese sulfate. So you need only one of those. Only one of those, right? So that means one SO4 minus is used. So that this becomes 23 as one is used. So then you have Fe3 plus ions. So to come up with the sulfates to neutralize them, you need to come and join these things with the negative ions. So sulfates valency, the 2 comes here. Fe's valency 3 comes here. That is how you are supposed to write that thing. So you need to provide, we need to come up with 15 Fe3 pluses, 15 Sp3 pluses. So to come up with 15 Sp3 pluses, so this should be 15 O2, right? No, 15 O2. If you have to come up with 15 O2 Fe, this compounds, right? That will give you 15 Fe3 pluses because 2 to 2 cancel off, right? So that I have written how many sulfate molecules, sulfate ions. So 3 into 15 is 45 O2, 45 O2, 45 O2 is, yes, 22.5. 22.5 sulfates are used here. So I had 23, so I had used 22.5, that means 0.5 is there, 0.5 sulfates are there. So just write the charge the species as it is. Finally, you have to write the existing here, right? So 1 K plus and 0.5 sulfates. So K plus and sulfates combines to give you K2SO4s. Exchange of valencies gives you K2SO4, right? But you have only 1 K plus and 0.5 sulfates. So this should be some half. Should come up with some half. Providing you 1 K plus and half of sulfates, right? So this is the equation, balanced chemical reaction, but we are not supposed to come up with half values as stoichiometric values in a normal equation. So we need to multiply this whole thing with 2 to come up with the final reaction. We need to multiply the whole thing with 2. So that will give you some 48 H2SO4 plus 2 of KMnO4 plus 10 of Fe3O4. We need to multiply with 2, right? Because you are not supposed to do the balanced chemical reactions with half values as stoichiometries, right? So when we multiply with 2, the 2 will cancel off. So 15 ferric sulfates. So this becomes 48. And this one is just K2SO4. So that is question number 6. Let's complete the stuff. Okay, Lama, let's try to solve the question number 7 here. Right? Number 7. So in acidic medium, NO3 minus ions react with Br minus to form the NO and the Br2 to provide the acid as well as the NO3 minus. To provide these, both of these guys, the HNO3 is used, and to provide the Br minus, the NaBr is used, right? Okay, so first of all, let's try to come up with the ionic equation, right? So this is balance ionic reaction. Right, let's write that stuff. No 3 minus and the Br minus, no? We do the NO and the Br2. Right, first thing is to balance the redox species. 1 nitrogen, 1 nitrate is balanced. 2 bromines, but only 1 bromine here, so you have to copy 2 here. That's the first thing to do, right? Balancing redox species. Next thing, right? Balancing the oxygen states. So you have minus 2 into 3 is minus 6. Minus 6 is there. So plus 6 minus 1 is plus 5. So here minus 2, that means this should be plus 2. 3 units of difference. Here minus 1 into 2 is minus 2. So minus 1, minus 1, 2 of minus 1, right? Minus 2. This 0, they remain 4. 2 units of difference. So balancing these two oxygen states, right? Differences, right? So the least common multiple is 6. So you need to multiply this thing with 3 to come up with 6. So this branch is multiplied by 3. That means this 2 becomes 6 as multiplied by 6. As you are supposed to multiply with 3, right? 2 into 3 is 6, right? So this also should come up with 3. And this thing should be multiplied with 2 to provide the least common multiple, right? So 2 here and 2 here. Second step is done, balancing the oxygen states. Next one, balancing the charges, right? So you have minus 2 here, you have minus 6 here, altogether minus 8. The charge here is minus 8. So you have 0 here and 0 here, just 0. So 8 units of difference, 8 units of difference. So 8 H plus should be added. 8 H plus should be added to the side with least positive nature, that is this side. So 8 H plus should be added here. The final thing is hydrogen balancing. You have 8 hydrogens at this side, and this side 0 hydrogens. So 8 units of difference with the hydrogens. So 4 water molecules are needed. 8 units of difference with the hydrogens. That means 4 water molecules are needed. So 4 water molecules should be added to the side with this number of hydrogens. That is this side. Right, no? So this is your balanced ionic reaction. Let's come up with the balanced chemical reaction. Right? So to provide the acid as well as the NO3 minuses, they had used HNO3s, right? So let's combine the two guys, right? So this is 8 H pluses, this is 2 nitrates, right? So we can write it as 8 HNO3s, 8 HNO3s, right? That will provide the 8 H pluses as well as 2 nitrates. After providing 2 nitrates, right, another 6 nitrates are remaining. Those are actually we have added by hand, right? So I have added 6 nitrates by hand, so that to come up with 8 HNO3s. The other 2 is provided by this one, right? Okay. So Br minus should be written as NaBrs, right? You have 6 of those. So I have added 6 Na pluses by hand when writing NaBrs, right? So 2 of NO plus 3 of Br2. We can write them as they are, right? Because those are chargeless species, right? Finally, you have 6 NO3 minus and 6 Na pluses, right? So those two guys combines to give you NaNO3, Na plus and NO3 minus combines to give you this, right? And 6 of Na plus and 6 of NO3 minuses are there, so 6 of NaNO3 should be formed, right? So this should cancel off after writing this, right? So that is your balanced chemical reaction, right? Just complete that stuff. This is question number 7. Okay, now let's try to balance the 8th reaction there, right? This is number 8, right? Okay. See, first let's come up with the balanced ionic reaction. Right. So first write the redox couples. H2SO4 is there, I minus, and H2SO reduces to SO2 while I minus oxidizes to I2, right? Okay. So let's write the stuff, right? First thing is balancing the redox atoms, right? So this is sulfur here, 1 to 1, that is balanced. So you have 1 iodine, 2 iodines here, so have to put 2 here, right? So redox atoms are balanced. Now the time to balance the oxygen states, right? So here minus 8 minus 2 into 4 is minus 8 plus 2, that is minus 6. So this should come up with plus 6, sulfur plus 6. Here minus 2 into 2 is minus 4, so this should be plus 4, right? The difference is just 2 units. So here minus 1 into 2, minus 2, minus 2 of minus 1s, right? Minus 2. So here 0, the elemental form. So 2 units of difference. So just balanced, right? So both should be multiplied with just 1, right? The least common multiple is 2, right? So no need of multiplying in the stoichiometry with any number, right? So the balancing of oxygen states is done, right? Okay, next one. Balancing charge. You have minus 2 charge here. You have 0 charge here. 2 units of difference. For that, you need to come up with 2 of H pluses. 2 of H pluses as the medium is acidic, right? So you can take the medium as acidic, right? So 2 of H pluses can be written here, right? Right. So finally, the hydrogen balancing. So you have four hydrogens, so we need to come up with 2 H2Os here, right? Okay, so that is your balanced ionic reaction, right? Let's try to come up with balanced chemical reaction as well. This is balanced chemical reaction, right? Okay, so to provide the H pluses, basically you have to use the H2SO4. Here the H2SO4 acting as the acid as well as the oxidizing agent, right? Both acid and oxidizing both provided by the H2SO4 here, right? So for that I can come up with H2SO4, one H2SO4, right? So this could be written as H2SO4. That H2SO and this H2SO becomes 2 of H2SO4s. So that I have added some SO4 minus ions by hand. So to provide the I minus, you need to come up with Ki. So 2 of Ki should be written as 2 I minus are needed. So 2 of K pluses are written by hand, right? So these are charged stuff, SO2, I2 as well as 2 of H2O. So I need to write this thing as we K2SO4, right? Because everything I have added by hand to the left hand side should be written at the right hand side as well. So K plus connecting with the SO4 2 minus to give you K2SO4. K2SO4, right? So that is balanced, right? Okay, that is the question number 8. Let's complete the stuff here. Right, now let's try to solve the question number 9, right? Okay, this is the question number 9, no? So first let's try to come up with the balance ionic reaction. Right, so you have MnO4 minus SNO, MnO2 and SNO2, right? Okay, first thing is to balance the redox species. One manganese here, one manganese here, one tin here, one tin here. Thing is balanced, right? Things are balanced, right? So now the balancing of oxygen states. So minus 8 is there with 4 oxygens. So plus 8 minus 1 is plus 7. So this is minus 2, that means this should be plus 2. So minus 4 appearing with 2 oxygens, so this should be plus 4, right? Here minus 4 is appearing, that should be plus 4, no? So the difference here is 3 units. Difference here is just 2 units, no? So least common multiple is 6, so you need to multiply this thing with 3, this branch with 3, right? Then this branch with 2 to compensate as 6, right? Okay, with 2. Right, no? Okay, so that is the balancing of oxygen states with use of this common multiple electrons, right? Then next one is to balance the net charge of the both sides. Here the minus 2 is the net charge at this side, so 0, right? So 2 units of difference, so you need to come up with some OH minuses here, right? OH minus is the medium. So how many OH minuses are needed? So you need 2 OH minuses at this side, right? Finally you need to balance the hydrogens there. So 2 hydrogens are there, so 1 H2 molecule is needed here, right? This is your balanced ionic reactions. Right now, okay, let's try to come up with the balanced chemical reaction as well. Right, you can write the H2 as it is, right? It is a uncharged species, charged species, right? So MnO4 minus should be written as KMnO4s, right? You have such 2 there, so 2 K pluses have been added by hand, right? So 3 of SNO is there, right? No need of writing, doing any changes because it's a uncharged species, right? 2 of MnO2, you can write the uncharged species as there, right? Finally, 2 of OH minuses. These OH minuses could be connected with the K pluses available here, so that is become 2 of KOH, right? The K pluses are used here now, right? So that is the final balanced chemical reaction for the 9th redox reaction, right? Just complete this stuff. Okay, now let's try to balance the equation number 10 here, right? Okay, so first let's come up with the balanced ionic reaction. Balanced ionic reaction, right? Balanced ionic reaction. So first write the species available there. Cr3 plus is there, H2O2. So you have the Cr of O2 minus and the OH minus, no? Right. Let's count the balanced chemical reactions. Balanced ionic reactions first of all, right? So balance in redox species first of all. So plus 3 here for the chromium. For this chromium it is minus 8 there with 4 oxygens. So plus 8 minus 2. Plus 8 minus 2 is plus 6. Right. So 3 units of difference, no? So I just forgot to balance the redox atoms here. Chromium, no worries, but for this case, right, it is the oxygen, right? It is the oxygen. Oxygen is the one showing variable oxygen states out of oxygen and hydrogen, because with hydrogens always when the non-metals are connected, hydrogen carries with +1, comes with +1, so oxygen should be the one which varies its oxygen state in this case. It's a special situation, right? Normally, as the redox species, we take the atom other than the hydrogens and oxygens, right? So, but here, as only the hydrogen and oxygen are available, appearing here, it should be the oxygen, right? Right? So, let's do the stuff, right? So you have 2 oxygens here. So to come up with 2, first you need to come up with the 2, right? Okay, balance in the redox atoms first of all, right? Then you can do the oxygen state balancing, right? So here, as 2 hydrogens are with +2, these 2 oxygens should carry -2, right? So here, hydrogen coming up with +1, so this one is -1 is -2, so such 2 guys are there. 2 of -2s are there, 2 of -2s are there, -4, huh? Right? So you can clearly see 2 units of difference there. Right? Okay. Now balancing, right? Oxygen state balancing, right? So 3 and 2, the least common multiple is 6. So you need to multiply this thing with 3. 3 here, 3 here. So multiplying this thing with 3 means 6. 2 into 3 is 6, right? So this is 2. This 2, right? Coming up with the least common multiple. So just put 2 here. Right now, that is done. So next step is to come up with the balancing the charges of the 2 sides with use of the medium. So you have +6 here, +6 and 0 here. So +6 at this side, -4, 2 of -2 particles, -4 and -6, -10 altogether. -10 altogether. So 16 units of difference. So 16 units of difference. So put some 16 OH minuses that to this side. So medium is basic, right? 16 units of difference. So 16 OH minuses are needed to side with this negative nature to this side, right? So actually you can cancel off before balancing the hydrogens. You can cancel off these 6 hydroxides, right? With some 6 here. So that is become 10 now. So 16 OH minuses, 6 OH minuses. That means altogether 10 here as a net amount, right? So then we can balance the hydrogens. So you have 10 hydrogens, 16 hydrogens there. So there is no hydrogens. So you need to come up with 8 H2Os there to provide the 16 hydrogens, right? No, so the thing is balanced, right? So that is the balanced ionic reaction of the question number 10, right? Okay, let's try to come up with the balanced chemical reaction as well. Balanced chemical reaction, right? So to provide the OH minuses, they had used KOH. So you can write 10 of KOHs, right? As you need to provide 10 OH minuses, 10 KOHs are needed. So 10 OH minuses have been written by hand, right? So to provide the CR pluses, they had used chromium chlorides, right? So to provide 2 of those chromiums, right? You need 2 here. That means you have added 6 of Cl minuses by hand, right? And 3 of H2O2s appearing. Then this one, you can use the positive ions available with you to neutralize this one. So positive ion available with you is what? So 10 K pluses, no, sorry for that, right? 10 K pluses here used, right? So you can come up with K2CrO4. So K pluses are used to neutralize the negative charges, plus minus, no? So to provide 2 of chromates, you need 2. So that means 4 of K pluses have been used. You had 10, so 4 is used. That means only 6 is remaining as K pluses, right? So the 8 formula is written, and finally you need to write this stuff to there, right? K plus and Cl minus will provide you KCl, right? And 6 K pluses and 6 Cl minus are there, so 6 of KCl should be the final answer, right? So you had used all of these guys ultimately when providing 6 of KCl there, right? Okay, that is how you are supposed to write the balanced chemical reaction for the question number 10, right? Okay, let's complete the stuff now. Okay, Ramay, let's try to solve these kind of special reactions here. So with the question number 11, right, you can see some special reactions are appearing. These are a bit different than the things we have learned earlier. Let's first examine what is the difference of these special reactions compared to the ones we had discussed earlier, right? The idea is this, Ramay. See, if you are to examine this thing, right, you can clearly see, right, you can clearly see the 2 ions here, right? One can write the 2 ions here as Fe2 plus and the C2O42 minus, no? Those are 2 ions available here, no? Right? If C2O42 minus, that is the anion, no? Oxide anion, right? So if you had to examine this thing, right, you would see the oxidation state of this thing is +2, and oxidation state of this carbon is actually, let's calculate that thing, this is -8. So this should get +6, +6 -2 plus -8, sorry, -8 -8 plus 8 minus 2 is +6 divided by 2 is +3. One carbon carry +3. But here you see this is +3, this is +4, right? -4 +4. So you clearly see, right, the 2 guys are oxidizing here. The Fe2 plus get oxidized. Not only that, the carbon here also get oxidized. So 2 atoms are involving in oxidation. 2 atoms are involving in oxidation, while the manganese stuff get reduced. So here the plus 7 goes to plus 2, it is normal kind, right? Some reduction could see with the manganese stuff, right? The special thing here is basically, right, in your single chemical reaction or ionic reaction, you could see two chemical species or two atoms are get oxidized. Two kind of atoms are getting or participating in oxidation. Just only in the oxidation, two atoms are involved, right? So this is a special kind, right? So let's examine how to solve this kind of reactions, right? With the straight balancing technique. This is a very important stuff, right? Okay, let's examine, right? Right, first we are supposed to write the balanced ionic reaction, right? Okay, we are supposed to write the balanced ionic reaction. That is what we are doing here, right? Right. First write the stuff, Lama. Right, first write the chemicals here. Plus MnO4 minus PVU, the Fe3 plus, and the CO2 and Mn2 plus, sorry. Right. First thing is actually balancing the redox atoms. Balancing the redox atoms. So one ion is there, one ion, that is balanced. Two carbons are there, so you should write it some 2 here, 2 carbons, right? Balancing the redox atoms. Then the manganese, one manganese is there, it is also balanced, right? Balancing the redox atoms, that is done. Second step, balancing the oxygen states. Balancing the oxygen states, right? As I have mentioned earlier, right? You could see that two atoms are getting involved in oxidation. What are the two atoms? The iron and carbon, both are get oxidized now. So balance the oxygen state of those guys at once. No need of taking the iron value, carbon value separately. Just take those values at once, right? So both of these guys, what is the number carried by both of these guys? So this is minus 8. 4 into minus 2 is minus 8. So these two guys should carry some plus 8. These two guys should carry some plus 8, right? So this is minus 8. So these two guys should carry plus 8 as the charge is 0. Summation of oxygen state of all the atoms should be equal to the charge there. The charge is 0. It should be plus 8, right? As this is minus 8. It's plus 8. What about here? So plus 3 is there. So 2 of oxygens means minus 4. So one carbon carry plus 4 is minus 4. One carbon carry plus 4. So 2 carbons are there, that is plus 8. 2 carbons are there, that is plus 8. So altogether the summation is plus 11. This is the oxidation half. Plus 8 oxidizes to plus 11. That is the oxidation half of this reaction. 11 electron difference. Sorry, 3 electron difference. Plus 8 and plus 11 means 3 electron difference. Right now? Next up, here minus 8, minus 2 into 4 is minus 8. So plus 8 minus 1 is plus 7. Here it is plus 2. Right? So the difference is just 5 electrons, no? 5 electrons. Plus 7 and plus 2, 5 electrons. So least common multiple is going to be what? Least common multiple is 15. 15. So you need to multiply this thing with, right? I'll come up with different values. I will need to multiply this thing with 3. That means this is 3. This is 3 for the 15, right? And you need to multiply this thing with 5, no? This thing with 5. I'm using different colors to get the idea clearly. So this thing should be multiplied with 5. That means this branch should be multiplied with 5. 5 here and these two things should be also multiplied with 5. That branch included these two guys, right? So this is 2 into 5 is just 10, right now. Okay, so that is the balancing of oxygen states. Next stuff, the next steps are actually normal steps, right? This is what you need to concentrate actually, right? Next steps are normal steps, right? See, balancing the charge. So at this side you have 0 charge here, 5 particles 0 charge, no charge contribution there. So 3 particles with -1, that means -3 is the charge there. So here 5 particles plus 3 means plus 15 is the charge. So 2 particles, so 3 particles plus 2 means some plus 6 is added. So plus 21 minus 3, difference is 24 units, 24 units of difference. So the medium is H plus, acidic medium, so 24 H pluses are needed at the side with these positive nature, this side, right? Finally, balancing the hydrogens, you have 24 hydrogens here, so 12 H2 molecules are needed, so we can come up with 12 H2Os here, right now. So that is how we are supposed to balance this kind of a special redox reaction. We are two components are actually, or two type of atoms are actually oxidizing, right now. Okay, just complete this stuff. Okay, Lama, let's try to solve this one as well. This is also a special kind of a reaction, right? Like in the earlier situation, let's try to solve this one, right? Okay, first of all, write the chemical species involved in the reaction before balancing, right? CO2 plus is there, SO2, and the Mn2 plus as well, right? Okay, in this case, right, the manganese is actually oxidizing, sorry, reducing. The plus 7 of Mn4 minus goes to plus 2, that is normal, right? That is normal, right? 5 electron difference, right? But the thing here is both the copper and sulfur get oxidized in this reaction. Both the copper and sulfur get oxidized in this reaction, right? If you need to know about that thing, see. So here the two ions available are the copper plus and the S2 minus, no? So that is how the exchange of valencies will give you the ions, no? So 2 of copper 2 plus guys are there, no? So the copper's oxidation state is here is +1 and here is +2, kind of oxidation, +1 to +2. Here -2 to +4, another oxidation. So copper as well as sulfur both get oxidized at this reaction, right? So it's a special reaction. So we need to multiply, we need to copy the answer like in the earlier situation, right? So go through the special technique of balancing that thing, right? So first of all, you need to balance the redox species, right? 2 copper atoms are available, so 2 here, 1 sulfur, that is okay. So now just balance the oxygen states, right? So for this one, 2 of plus 2s, 2 of plus 2s, 2 of plus 2s, right? Okay, so altogether charge here is +8, no? +8, right? What about this? So sulfur and copper, so both just take as a one particle, right? So the net oxygen state should be 0. Net oxygen state should be 0. Should be 0, right? Because summation of oxygen state is equal to 0. So only these two guys are available. So that is 0. So the oxygen state difference coming from here is actually 8 units. 8 units, right? Okay. Let's try to balance the stuff. So the least common multiple is 40. Least common multiple is 40. So multiply this thing with 8, multiply this thing with 8. It's 8 here. So to come up with 40, you need to multiply this thing with 5, right? This thing with 5. I'll write it in red color to understand properly, clearly. So multiplying with 5 means you need to come up with 5 here. All the chemicals with the branch should be multiplied with 5. And for these two guys, you should multiply the 2 with 5. That means it becomes 10. And this thing also should be multiplied by 5, right? That is the balancing of oxygen states, right? Next point is actually balancing net charge. So you have minus 8 charge here, minus 8 charge at this side. So this is 0, this is minus 8. So you have 10 particles plus 2, that is plus 20. And you don't have charge here, but here 8 particles plus 2 is plus 60, plus 60. Altogether plus 46, right? Plus 46. Clear, no? It's 14, no? Yeah. So this is plus 8, 0, 8 is difference, 5, right? So come up with 5. So this is just 5 units. That means you have to count 8, right? Okay. So plus 20 plus 16, it is 36, no? It is 36. 36 there. This is 8. So the difference is 44 units. Difference is 44 units. So you have to add 44 units of H pluses to the side with least positive net, as the medium is acidic, right? So you will come up with 22 H2Os to this side to provide 44 hydrogens, right now. So that is how you're supposed to balance this equation, right now. Okay, that is clear. Okay, Lama, let's try to balance this one, right? Third one, the third special reaction here, right? Okay, see how to balance this stuff. First of all, write the chemical components in your reaction, right? Cr2O7 is also there, SN4 plus, NO3 minus, and Cr3 plus, right? First balance the chemical species first of all, right? So you have one tin there. So 2 of nitrates, just put 2 here. 2 of chromiums, just put 2 here, right? 2 of chromiums, no? Right? Now balancing the oxygen states. So in this case, the only one get reduced is the chromium, right? So first write that thing. So minus 14 is there. So plus 14 minus 2 is plus 12. So here 2 of Cr3 pluses, that means plus 6. So altogether the difference is going to be 6 units. It's okay. What about here? Here the tin 2 plus is appearing. That is oxidized to tin 4 plus. 2 plus oxygen state came to 4 plus oxygen state. Here the nitrate ions NO2 minuses, right? So if you were to examine this thing, nitrate ion, the nitrate will come up with plus 3 oxygen state. Nitrite ion NO2 minus, NO2 minus, NO2 minus. The nitrate will come up with minus 1 come up with plus 3 oxygen state. And here for the nitrate is with plus 5 oxygen state. So plus 3 has oxidized to plus 5. Plus 2 here, tin oxidized to plus 4. So 2 atoms get oxidized in this case, right? So the special balancing technique should be used, right? So let's balance the stuff, right? So with this thing, it is plus 4 oxygen state here. With 3 of oxygens, it is minus 6. So plus 6 minus 1 is plus 5. So such two nitrogens are there. Plus 5 into 2, right? Okay. So altogether, this side carries some plus 40. Right? What about here? So we need the summation of oxygen states of nitrogens and teens, right? So you have 4 oxygens altogether. 2 oxygens here, another into 2 is 4 oxygens. 4 oxygens carry -8. 4 oxygens carry -8. That means all of the other atoms should carry +8. Got the idea? As 4 oxygens are available here in this molecule, 4 oxygens carry -2 into 4 is -8. So other atoms should carry +8. The other atoms means the wanted 2. The tin and iron. The summation is that is what we are referred to, right? So the difference here is how many of difference, right? 6 electron difference, right? So 6 electrons are balanced. So the oxygen states are balanced here. No need of multiplying with any number, right? Okay. Right. Next stuff is the charge balancing. It's a charge balancing. See, balancing of charge. So here the charge is 0. Here the charge is -2. Particle with 0 charge and particle with -2 charge. That's -2. Here the charge is +4, -2, and so 2 particles plus 3 means +6. The charge, no? So altogether the charge is +8, no? +8. +8 and -2, that means 10 units of difference. 10 units of difference, right? +8 -2 is 10 units of difference, right? So you need to add 10 H pluses to the side with least positive nature. This is side, right? H pluses. So then you have to balance the hydrogens with use of water molecules. So 10 hydrogens difference is there. Difference of 10 hydrogens are there. That means it should be what? So you have it 10 hydrogens at this side, and that side you don't have any hydrogens. So to provide 10 hydrogens difference, you need 5 of H2 molecules. So that should be added to side with least hydrogens, right? This side, right? No? So that is how you are supposed to balance that equation, right? No? Okay. So that is it for this session, right? What we have done is actually the straight balancing technique, right? We had done the question number 10 and 11 as well. Those ionic equations as well as the chemical equations use the use of straight balancing technique, right? That is what we have learned with this lesson. Okay, then with the next lesson we'll discuss about how to solve the chemical calculation questions with the use of these balancing techniques, right? We'll meet then. Until then, goodbye.